Hi everyone, in this video I will walk you through how I improve the performance of my classifier. The model I compared is the technique I used to assess to refine and fit. I also discuss handling the class imbalance and the potential feature improvements. For improving the performance of the classifier, I focus on the feature engineering, the model selection, and the hyperparameter tuning. I use my model to more effective. I start with the feature engineering, which is here. Here, the feature engineering. I create a new feature such as the debit to income ratio, the loan interest burden, and the employment experience ratio. This feature provides better insights to browser and the financial situation and improves the prediction accuracy. Next, I assess the class imbalance in the dataset. Since years were more proved loans than the rejected ones, the model would easily for appeal for fictitious. I used the SMOTE and the SMOTE TOMAC, which helps the balanced data by generating the synthetic samples and removing the overlapping data points. This ensures that the model learns pattern from the both approved and the rejected loan more fairly. I also applied the Searsold turning to adjust the decision boundary instead of relying on the default classified Searsold of 0.5. I used the precision record curve here to find the optimal value that reduce the risky loans approve while still allowing the enough approval useful. One major challenge was class imbalance, which would cause the model to favor the majority class. To address this, I experienced with the different techniques. First is SMOTE. This generates the synthetic samples to balance the dataset and helps the model learn better the decision boundaries. Also, the class weightings assigned the high weights to the minority class helped penalize the misclassification, especially in the model like the logistic regression. And lastly is the Searsold turning. Instead of using default of 0.5 probability Searsold, I optimized the decision boundary based on the precision record trade-off, minimize the business risk. I also performed the hyperparameter using the root search CV and the random site search CV. For instance, I turning the learning rate and the max dips in the XGBoost significantly improves the performance. Before turning, the F1 scores were really low due to the overfitting and underfitting, but after adjust the parameters, the model were achieved by the generator. Is here. Okay. I trained the two models, including the random forest. Here, the GT ball. I trained the two models, include the random forest and XGBoost, which all those had a strength random forest handles non-linear well. XGBoost provides a strong predictive performance. I evaluate these models as F1 scores to balance the precision and recall, ensuring the model worked well for both class. The evaluating model fits, I used the K for the cross-validation instead of the sample train test split. This provides a most estimate of performance by ensuring all the data points were used for both the training and the data test. To further assess the performance, I examine the confusion matrix, which is here, the precision recall curve and ROC curve. The ROC curve helped visualize the trade-off between the sensitivity and the specificity, allowing me to select the optimal decision Searsold based on the area under the AUC. In a loan appeal setting, the false positive are riskier than the false negative. By addressing the decisions they are sold, I'm aimed to minimize the financial loss while maintaining the farmlands. Here is the graph. For the future improvements, if I had more time and resource, I would explore external data sets such as the microeconomic indicator or the credit bureau data to enhance the predictive accuracy. Additionally, implementing the model monitoring system would help to detect the data drifting and ensuring the classifier remained reliable in production. Overall, improving the classifier is a iterative process involving the feature engineering, the model selection, the class imbalance handling, and the violation techniques. By combining these strategies, I was able to improve my model predicting power while address the business consideration. That's for my presentation. Thank you for watching.